Alrighty, so we're recording now. So you know your homework was simply working on like the basics of the circle, all right? So we had, what is a circle, what are radii, what's a chord, what's a diameter, and then we talked a little bit about like the relationship between the measure of a radius and a diameter, and then how do you find the circumference of a circle if you know either the radius or the diameter, all right? So just really quickly reviewing, right? Really quickly reviewing, we know that, so if I said to you, if you have a circle, right? What would we call this circle? We would call it circle A because you name a circle by the center, right? And the definition of a circle is all the points equidistant from a given point called the center, okay? Now, a circle gets hard to deal with because it's curved. So what we do is we use certain line segments. So the first line segment we talked about was this one right here. A line segment whose two endpoints are a point on the circle, B, and the center of the circle, A. And we know that AB is called a radius, right? That's the definition of a radius, right? Now, the second one we talked about was something that looks a little bit like this, all right? So this is C and D, all right? And if I draw that line segment, right? Line segment CD is what we call a chord. And a chord is any line segment, right? Where the endpoints are points on the circle. And then finally, the last one we did was we did a chord that passes through the center of the circle. So EF, it's a chord, but it passes through the center, so we call it a diameter. Now, let me get rid of a few things here. If I get rid of this, right? What do I notice? What do I notice about EF? Well, EF is made up of two segments, right? AF and AE. Now, based on the definition, what do you call this? You call it a radius. And what do you call this? You call it a radius. So what's the relationship between my diameter and my radii? The diameter is simply 2 times the radius, right? So you just have to remember that until the day you die. That's how important that is. Make sense? All righty. Then the second thing we talked about was finding the circumference of a circle. And circumference means the distance around. And we have two different formulas we can use. They're both the same. Pi d, pi times the diameter. Or if we have the radius, we can just use what the radius is. The radius, 2 times the radius is the diameter. So 2 pi r. So either one of these we can use to find the circumference or the distance around the circle. Not that big a deal, right? Yes? Hello? All righty. So far, so good? So far, so good?
Yes.
All righty. All right. So now on to today, right? So today, right? What are we going to try to accomplish today, right? So today, what we're going to try to do, right? We're going to try to find the measure of an arc of a circle, right? So today, what we want to do is we want to try to find the measure of the arc of a circle. That makes sense to you in a few minutes. And your homework, right, your homework, I'm going to put it in Blackboard for you. It's a little worksheet, right? It's going to be the worksheet page 125, and just do numbers 1 to 14. All right? And that'll be due Friday evening. All right? Is that understood? Hello?
Yes, sir.
All righty. And all we're going to be talking about is finding the measure of an arc. All right? And then we're going to do some work on that. And then we'll see how it works, and then we'll go from there. Comprende?
Sir.
All righty. So far, so good? Nothing. This isn't brain surgery, by the way. All right. So the first thing we want to talk about, first thing we want to talk about today is this idea of a central angle. Well, here's what we know. And it's obviously an angle, all right? So a central angle is any angle whose vertex is at the center of a circle. All right? Any angle whose vertex is at the center of a circle, right? So, for example, here is circle A. This angle right here, angle BAC, is a central angle. Why? Because its vertex is at the center of the circle. Hey, fellas, what do you know about these two sides of the circle, these two legs? What would you call them?
Radius.
What are they?
Radii.
Radii, good. The two legs are radii. So what's that mean? They're the same length, right? Yes?
Yes, sir.
All righty, so don't ever forget that. Now, let me clear this up a little bit, right? Let me clear a little bit of this away, right? Hold on. So far, so good. Now, we're going to keep the same picture here, right? So make sure we know, hey, fellas, in geometry, it's really important that you know these definitions. Because when you know the definitions exactly as they're written, you actually know the information. All right, so here I have angle BAC. Now, I could also call it angle CAB, right? Doesn't matter as long as A is in the middle. Why does A have to be in the middle? Because A is the vertex, right? Now, look at what it does. Now, just so you know, like this goes on forever, and this goes on forever, but the only part that we care about is the part that intercepts the circle. Now, we say that angle BAC intercepts an arc. All righty, so first thing I want you to look at. See this part of the circle right here? The part between B and C. That's called an intercepted arc. So we would say that angle BAC intercepts arc BC. Okay? That's supposed to be a bit of an archy figure. Okay? So sort of like, and we would just say that would be arc BC. Whereas if we went like this, that would be line segment BC. Does everybody understand that? Hello?
Yes.
Sir.
All right. Now, there's also another arc that gets, if angle BAC intercepts this arc, well, we also have this part of the circle as well, from B to C. But if I was talking about that part of the circle or that arc, I would have to name it differently than BC. It's going from B to C, but it's not going this way. It's not going this short way. It's going the long way. So I would call that arc BC, but it passes through D. Does everybody understand that? All right. Now, getting a little bit ahead, I call the shorter arc the minor arc. I called the longer arc the major arc. Does that make sense? All righty?
Yes, sir.
All righty. Now, I haven't even talked about measuring them yet. I'm just introducing the idea. Okay? So far, so good. All righty. Now, if we look at this a little bit closer, I'm gonna, yeah, let me clear the whole thing. Sometimes we have an angle that's a straight angle. Okay? That's still an angle, gentlemen. So we wouldn't call one of those arcs minor and the other one major. Why? Why?
Because they're both the same.
They're both the same. And they're, what is this? What is this line segment called? What do you call that line segment? Is that a radius? It's a diameter. So here's what we know about AB. Arc AB would be what we call a what? What do you call that? What's arc AB?
Semicircle.
A semicircle. So if you have a diameter, that's a straight angle, right? And a straight angle will cut the circle into two equal arcs. But we're going to talk about that in a second, right? So far, so good? So far, so good?
Sir.
Okay. All righty. Now, we didn't say we were just going to define these things for you. We said we were going to find what? We were going to work with finding the measures of an arc, all right? Well, if I have a circle, and I have a picture like this, well, obviously, right, I see two arcs there. I see arc AB, and what's the other one called? Arc ACB. Which one would be the minor arc?
AB.
Yeah. Well, this is the minor arc, right? And the other one, A to B through C, would be the major arc. Now, we can find the measure of arcs, okay? And the way you do that is by using what you know about the measure of this angle, okay? This central angle. So if I told you that the measure of angle AOB was 50 degrees, okay? Let's not make it 50. Let's make it, I don't know. Let's make it 68 degrees. So this picture right here, right? This is 68 degrees, okay? The first rule that you have to understand is that the arc that is cut by this angle, the arc that is intercepted by this angle has exactly the same measure as the central angle. So the minor arc has the same measure as the central angle that cuts it. Now, if I started here and I went all the way around the circle, how many degrees is that?
360.
360. So now you're going to use your intelligence that God gave you and tell me if arc AB measures 68 degrees, What does arc ACB measure?
292.
Well, here's what we know. It would be 360 minus 68. Agreed? Yes? Hanan? Hanan?
Yes, sir.
And we know that that's 292. Does that make sense?
Yes,
All
sir.
right. So we know that the minor arc is going to be less than 180. The major arc will be greater than 180. But we do know that if you have two arcs in a circle, right, you could have more than two arcs. But if you only had two, all the arcs of a circle have to add up to 180. So if you have a semicircle, what's the measure of the arc cut by a semicircle? That equals 180. Does that make sense? What's the measure of a straight angle? 180, right? Does that make sense, guys?
Yes, sir.
All righty. Let's try a few problems here. Ready? So if I give you this picture, this is going to be circle O. So here's what I got. I got circle O, and I got points A, B, and C on the circle. The measure of angle BOC equals 50 degrees. That makes sense, right? Head in. Head in. Somebody tell me the measure of arc AB. Well, where is arc AB? Well, arc AB goes from point A over to B.
130.
What would the measure of that be? Well, the measure of that would be the same as the central angle that cuts that. But that's right here. That's right here. But they didn't tell me that angle. But they did do what though, fellas? This is a straight line, right?
Another, yeah.
What's the measure of a straight line? What's the measure of a straight line?
180.
180. So if this is 180, what's 50? What do you add to 50 to get 180?
130.
So that angle right there is 130, which means the measure of AB is 130. So you do it two ways, fellas. You can do it two ways. If you know the angle, you know the measure of the arc. If you know the measure of the arc, you know the measure of the central angle. Comprende? That's not brain surgery, by the way, right? All righty. Here's the next question for you. What's the measure of arc BAC? Well, which arc is BAC? It's from B to C. So it's this one, right? Hello?
Yes, sir.
No. How do you know it wasn't that one? What's it say?
B to A to C.
B
So-
to C through A, all right? B to C through A. So I'm going to go from B to C, but I'm not going this way. I'm going through A. All righty. Well, what do I know? I do know this is what? This is 50, right? So if from B to C is 50, what would it be from B to C going the other way?
310.
Thank you. Because a full circle is what?
360.
360, and this portion of the circle was 50. So there you have it. All right? One last question. What is the measure of arc AC?
180.
Yep. How come I didn't say ABC? What's the measure of arc ABC?
180.
Yeah, 180 is what? Fellas, it's a diameter. So it's a diameter, it's a straight angle, right? And it cuts the circle into two semicircles, right? Not too bad, right? Now, how many different arcs do you see here, fellas? Ready? What? We got 1, we got 2, and we got 3. And what do they all add up to? 360. Remember, a full circle equals 360 degrees. So if your circle is broken into 3 arcs, the 3 arcs have to add up to 360. If it's broken into 6 arcs, it has to add up to 360. It always adds up to 360. Does that make sense? Hello? All right, let's try another one. Draw a nice little picture for you. This one's going to have a few more arcs on it. All right, so this is going to be circle P. All right, so we have E, C, A, B, D. Okay. I'm going to move D for a second. All right. I'm going to move D because I don't want you to think it's actually a diameter, because it's not. All righty. So there's what I've been given, and here are some of the measures that I know. This is 70. This is 40. This is 20. All right? So there's what I know. Angle E, ready? Angle EPA is 20 degrees. Angle BPC is 40 degrees. And angle CPD is 70. Well, sometimes when you do these, you might fill in numbers you already know, right? So let's look at the measure. What is the measure of arc AB? Well, arc AB is here. What information do I need to know in order to answer that? I need to know the measure of the central angle that cuts that. Now, based on the information they gave you right there, what is that angle measure? What do you see here, fellas?
120.
What is this? It's a straight line. That's a straight line, right? What's a straight line add up to? What's a straight line add up to?
80.
180, right? What's 40 and 20? 60. So what's this have to be?
120.
120. So that's what? 120. Not a big deal, right? Second question for you. What is the measure of arc ACE? Well, we're going to go from A to E, but I'm not doing the short one. I'm not doing this one. Why not? Because they told me what? What did they tell me? What's that C in the middle mean? What's that C in the middle mean?
3C.
Go from A to C, but A to E, but go through C. All righty. Well, what do you know about that? Okay. So from A to E this way is 20. So what's it from A to E the other way?
340.
Yeah, 340. Why? Because the minor arc and the major arc are going to add up to 340, right? Makes sense, right? Next one. What's the measure of arc EC? C. All right, well, here's E, and here's C. What is that?
180.
That's a diameter, and the
180.
diameter cuts it into a semicircle. And what's half of a circle? 180, right? Makes sense, right? And then finally, what's the measure of arc ED? Well, here's 70. What's this? If this is 70,
110.
110, right? Forms a straight line. Does that make sense for you guys?
Yes, sir.
All righty. Comprendes? Not a big deal, right? Not a big deal, right?
Yes, sir.
All righty. So far, so good? Hello?
Yes, sir.
All righty. All righty. Sometimes you get an arc, but that arc is not cut by an angle, it's cut by a chord. So I do have an arc here. I do have arc AB. Everybody see arc AB? Yeah?
Yes,
Here's
sir.
what you need to remember. Now what do I have? What kind of angle is that called?
Central angle.
It's a central angle. So what you need to remember, fellas, is this, that sometimes when they give you a chord, they're giving you arcs. But you got to remember that that can be actually formed by a central angle. So don't ever forget that. So even though you have an arc that's cut by a chord, right, it's still the measure of the central angle that determines the length. Now, somebody tell me, what do you think the relationship between these two things is? What's this one? What's the difference between these two things? This one's a segment, right? This one's an arc. How do you know one's a segment?
Got the straight line above it.
And then the other one has an arc above it, right? Hey, what do you think the relationship is? Less than, greater than, equal to? Do you think this line segment is less than the length of this, more than the length of this, or the same?
Less than.
Hey, fellas, what's the shortest distance between 2 points? A straight line.
Yeah.
So as soon as you make an arc out of it, that arc is always going to be longer than the chord that cuts it, right? And that's what you need to remember when you do this, right? So like you see that picture, you need to remember that, right? Does that make sense to you guys?
Yes, sir.
All righty. So I just want to make sure I got a little bit ahead of myself, but we're going pretty good. So does anybody have any questions on finding the measure of an arc? All righty. Well, now we're going to go find the length of an arc, right? So now we're getting a little more work done than I thought, right? The length of an arc. There's a difference between the measure of an arc and the length of an arc. The measure of an arc is out of 360. The length of an arc, all right, well, let's figure it out here. Let me draw you a picture. If I give you this picture, what's the measure of arc AB? What's the measure of arc AB?
50.
50. Good. Let me change the picture for you. Let me ask you a different question. The radius is 6. How far is it from A to B? Now notice, I didn't say what's the measure. I said what's the length. Now you have to do a little bit of thinking, right? The measure is out of 360. Because it's 360 to start at point A and go all the way around the circle, start at point A and go all the way around the circle and get back to point A. That's 360 degrees. If I was talking about length, what do we call the length all the way around the circle? You did it for your homework.
Circumference.
Very good. So, when you actually talk about the length of a circle, the length of an arc, you're going to write a ratio, a proportion between two ratios, fractions. Right? So let's watch what happens. Watch what happens here. In this problem, I know the measure of arc AB is 50. But if I ask you for the length of AB, well, whatever portion, what's the central angle that cuts that arc? 50 degrees, right? Whatever the arc measure is out of the full circle is equal to the length of the arc out of the circumference. Right? The measure, right? If you look at this, the measure 50 degrees, my central angle's 50, so this is 50. Whatever that number is out of the full circle, the arc measure out of the full circle, that has to be the same as how far it is from here to here, the length out of the full circle. What do we call that? The circumference. That's all. That has to be true. So based on that, I can give you a formula. I can give you a formula for finding the length of an arc, right? And the length of the arc is simply what? 2 pi r times whatever the measure of the arc is out of 360. Okay? Now, why 2 pi r? Why 2 pi r?
That's the circumference.
Yeah, that's the circumference. So if I look at this picture, right? If I look at this picture, let me get some of this out of here, right? All right, so what have they told me? Do I know the radius? Do I know the radius?
Yeah.
Look at that picture. Yeah, I know the radius. What is it? It's 6. So guess what I can do? I can take my formula. Let me write it up here. 2 pi r times x over 360. Remember, we're trying to find AB. Well, what's the measure of AB? 50 degrees, right? Out of 360, so I put the measure, x equals the measure of the arc. So I just substitute, right? I substitute in here with 50, right? Let me get some of this away. And now all I got to do is start doing some work. What's 2 pi r? What's 2 pi r? What's r? What's r? 6, right? Yes? What's 2 times 6?
12.
12 pi times 50 over 360. All right? And then if you do that work, what do you get? If you take out your calculator, you get about 5.24. Does that make sense? Does that make sense?
Yes.
All righty. Getting a little bit ahead of myself, but that's all right. Not too bad. Let's see. Does that make sense to you guys?
Yes, sir.
Let me see if I can give you another. I just got a little bit ahead of myself, so I didn't think we'd get this much done today. Let's see if I can give you a little bit more. Let's see if I can give you. Give me one chance to get another example for you. All right, we're gonna find the. All right, here we go. I'll give you a new picture here. Here's your circle. All right, I'm gonna put a little center there. Boom. Boom. And here's what I know about this circle. All righty. Now, if I said to you, what is the length of the arc, right? What is the length of the arc of AB? Now, I know what the measure is. What's the measure of arc AB?
180.
It's 180. How do you know it's 180?
Straight line.
Because AB is a diameter. So it cuts. So I know the measure is 180. But I don't want to know the measure. I want to know the length. I know the diameter is 10 centimeters. So what do? Well, my formula for the length of an arc is always equal to 2 pi r times the measure of the arc over 360. Well, I don't know the radius. They gave me the diameter, but the radius is what? Half the diameter. But what's 2 times the radius?
Diameter 10.
The diameter. So I don't need to write 2 times pi times 5. I'm just going to write pi times 10, or 10 pi, right? Yes? Yes?
Yes, sir.
All righty. If this is the arc I want to know, the length of the arc, I need to know the measure of it, and it's a semicircle, so it's 180 x. X is always the measure of the arc over 360. And now I just have to multiply. Hey, fellas, what am I going to change 180 over 360 to?
1/2.
180? Yeah, 1/2. So what's that become when you multiply that?
15.7.
You got 10 pi over 2, and then that's what? 5 pi. So 5 times 3.14. What do you got? 15 point? Was it 7.1?
Yep.
Something like that, right? And that's how long it is. That's a measure of length. That has nothing to do with measure of like angles and stuff like that. All right? But I got a little bit ahead of myself there. Probably got a little bit ahead of myself. All righty? So, big takeaways from today. All right? You need to know the idea of an arc. Right? And an arc is cut by a central angle, right now we only have central angles, right? And the measure of an arc is always equal to the measure of the central angle that cuts it, right? Now, an arc could be minor, it could be major, right? It could be a semicircle, right? Does that make sense? So if it's minor, we know that it measures less. If it's minor, we know that it measures less than 180 degrees. If it's a major arc, it's going to be greater than 180 degrees. And if it's a semicircle, its measure is going to be equal to 180 degrees. Does that make sense? Hello? Hello?
Yes, sir.
All righty. Now, if you add up all the arcs of a circle, what are you going to get? What are you going to get?
360.
Yeah, you're going to get 360. All right. Does that make sense, guys?
Yes, sir.
Anybody not understand that? Hello? All righty. So, that's all I got for today, guys. Because I don't want to get too far ahead. I want to make sure you do some work and make sure you know what the hell you're doing. Does that make sense?
Yes, sir.
So,
All right. Now, some of you, I think, have to see me, right? Hold on one second.